Hey everyone, we're going to continue our work with compound inequalities today in lesson 4.4. So we'll more practice solving compound inequalities and then graphing compound inequalities. So that's our aim today, solving and graphing compound inequalities. Compound inequalities are used in mathematics for a variety of purposes. It's good to get more practice in them, especially when it comes to visualizing what values of x lie in the solution sets. So exercise 1 says graph each of the following compound inequalities on the number lines provided. For C and D, write the inequalities as a single statement. So that's something new we're going to talk about. So first let's do A and B. Okay, x is less than 1 or x is greater than or equal to 4. So I'm going to make an open circle. So I'm going to do this one first. I'm going to make an open circle on 1. And then I'm going to make a line to the left. That's less than 1. Or x is greater than 4. That's going to have a closed circle on 4 and greater than. So that's my graph of letter A. Letter B, x is greater than 7 or x is less than -2. So x is greater than 7. I have an open circle on 7 and it's going to the right. And for x is less than 2, I have a open circle on -2 and it going to the left. Okay, let's take a look at the AND inequalities. There's a little bit of a different rule with the ANDs. So I have x is greater than -3 here. So x is greater than -3, so I'm going to put an open circle on -3. And x is less than 5, so an open circle on 5. Because it's and one's greater, one's left, we connect it this way. Now, the other additional thing we have to think about, and that's this direction right here at the very top, that says, for C and D, write the inequalities as a single statement. We have a special notation when we have numbers that are between two, when we have an inequality that's between two numbers. So do you see how this inequality is between -3 and 5? So I can write this, and this is called set notation, is I can say x is between 3 and 5. Okay? It's like breaking up your inequalities, but putting it into one whole thing. Okay? It's called set notation. Letter D, let's graph first. X is less than or equal to 9, so I put a closed circle on the 9. In the next one, x is greater than or equal to 0, so a closed circle on 0, and I connect them this way. As a single inequality, what two numbers is this between? It's between 0 and 10. So I'm going to put x is between 0 and 10. Notice I'm keeping my same inequality signs here with less than or equal to. Okay. Inequalities involving and are almost always universally written as a single inequality because these tend to show us how all values of x are between two numbers. Okay, so this is showing that x is between -3 and 5. It's easier to read than saying two separate inequalities. And we're going to get more practice with this in the lesson. Okay. Exercise 2. Graph each of the following, but first rewrite as two inequalities involved again. So now A and B start us off with set notation, and now we have to take it and break it into two different inequalities. This can be kind of tricky. So I'm first going to look at this part here. -4 is less than or equal to x. I don't want to write this. Don't write this. Whenever you have an inequality, you always want x to be on the left-hand side. Right now, x is on the right, so we have to flip this inequality and switch the x and the -4. When I switch the x and the -4, I also switch the inequality sign to get x is greater than or equal to -4. Okay, so that's your first inequality. So when I write on my paper, I'm going to say, okay, the first part of this is x is greater than or equal to -4. Okay, now I have, that was this first part here. Now I have the second part, which is the x is less than -6. So I can say, and x is less than 6. Okay. The tricky part is converting this -4 less than or equal to x into x is greater than or equal to -4. That conversion. Okay. Now that I've converted both of them, I can graph them. So I have -4 as my lowest And it's a closed circle because it has the equal to, and an open circle on 6 because it doesn't, and I connect them with my line. Okay? Letter B, same thing. We're going to split the two inequalities. So my first one is this -5 is less than or equal to x, but I need to convert that by switching the x and the -5 and flipping the inequality sign. Okay? So my first part, oops, I'm sorry, that should say x is greater than 5. So now I say, okay, the first one is x is greater than or equal to -5, and then the second one is and x is less than or equal to 9. Okay? Now we graph. X is greater than or equal to -5 is an open circle on -5. X is less than or equal to 9 is a closed circle on 9, and we connect them to graph. Okay? All right, exercise 3. For each of the following graphs, write a compound inequality that describes all the numbers shown graphed. So now we've done three things. I've done two things so far. The first thing we did was we took separate inequalities and graphed them. And then we wrote it as a single inequality. So going from two inequalities to a single inequality. The second thing we did was we took a single inequality and broke it up into two different inequalities. Now we're taking a graph and going backwards and writing the inequality. Okay, so I'm looking at A, and I'm going to take a look at the numbers that it stopped on. So this first number on the left one starts on a -1. So I'm going to go ahead and label that in here. That's a -1. So this is x is less than -1 because the arrow is pointing to the left and it's got an open circle, right? That means it's a less than symbol. That's my first one. The second one, this is an OR statement because there's nothing in between, so this is an OR. And then on my right, I have a number starting at 5 and going to the right with an open circle, so that means x is greater than or equal to 5. When it's going to the right, that is a greater than or equal to sign. Okay? Letter B, this is an AND statement because it's got the connected to both. I'm going to label this as a -8, and this is labeled as a 2 on my number line. So I can write this two different ways. I can write it as something x is between 8 and 2. Now I'm going to want open circles here. I want less than signs. So I can write it in this notation where x is between -8 and 2. Or I can write it as two separate inequalities. I can say, well, -8 is less, I can take this first set, -8 is less than x, and rewrite it as x is greater than -8, or x is greater than, x is less than 2. So either way, this answer or this answer are both correct for letter B. Okay? This notation you're going to see a lot more often than this notation. Oh, I'm sorry, this should be and. I'm having all kinds of problems today. Okay? All right? Exercise 4. Now we're going to put everything together, and we're going to solve inequalities. So we were just working with simple numbers, now let's work with going back and solving inequalities and applying what we just learned. So exercise 4 said, consider that a compound inequality given by 6x plus 1 is greater than or equal to 4, and -2x plus 8 is greater than -12. Letter A says, determine whether each of the following values of x falls in the solution set to this compound inequality. Show the work that leads to the answer. So what is this saying we have to do? It's saying we have to plug in. So this is saying plug in. All right? So I have x equals 5. So I'm going to say, okay, 6 times 5 plus 1 is greater than 4, and -2 times 5 plus 8 is greater than -12. So that's my first one I'm evaluating. 6 times 5 is 30. 30 plus 1 is 31, greater than or equal to 4. Is this true? Yes. So the first part's true. But for an AND statement, remember, both of them have to be true. -2 times 5 is -10. Bring down the 8 and then negative 12. Negative 10 plus 8 is negative 2. Is negative 2 greater than negative 12? Yes. So this is true. Alright, so we found one value of x that could work. Let's try x equals negative 3. So I have 6 times negative 3 plus 1 is greater than or equal to 4. And negative 2 times negative 3 plus 8 is greater than negative 12. So remember, I'm just plugging in my values into these two inequalities and seeing if it's true or not true. 6 times negative 3 is negative 18. Bring down the 1 and the 4. Negative 18 plus 1 is negative 17. Is negative 17 greater than or equal to 4? No, that is false. Right away, I know that this is not going to be true because both have to be true, but let's go ahead and finish solving the other one, or simplifying it. Negative 2 times negative 3 is a positive 6. 6 plus 8 is 14. 14 is greater than negative 12, but because it's an and, both have to be true, so this is still a false number. Negative 3 will not work for this inequality. And finally, let's test number 10, the number 10. I've got 6 times 10 plus 1 is greater than or equal to 4, and negative 2 times 10 plus 8 is greater than negative 12. So 6 times 10 is 60, plus 1 greater than or equal to 4. Negative 2 times 10 is negative 20. Okay. 60 plus 1 is 61. Is 61 greater than or equal to 4? Yes, so that side's true. Negative 20 plus 8 is a negative 12. Is negative 12 greater than negative 12? No. If this had an equal to under here, it would be true, but it doesn't have the equal to, so this is false. So this whole thing is false. So we're testing this because you can see that it would take a very long time to try and figure this out by guess and check, right? So we're just trying to get a sense of what this inequality is looking like, right? I know that the number 5 works and the number 10 doesn't work. So my solution set is somewhere around 5. But let's go ahead and solve this so we can get an exact solution instead of doing guess and check work. So letter B says solve the compound inequality and graph its solution. So to solve a compound inequality, you have to solve each one separately and then bring them together. So I'm going to start with the first one. So I'm going to start with the 6x plus 1 is greater than 4. So 6x plus 1 is greater than or equal to 4. And negative 2x plus 8 is greater than negative 12. So I'm just rewriting the problem. Now I'm going to solve each one. So to start solving, I'm going to start getting x by itself. So I'm going to subtract 1 on both sides to cancel out the 1's. I'm left with 6x is greater than or equal to 4 minus 1 is 3. Divide both sides by 6, and I get x is greater than or equal to 1/3. Alright, so that's the first part of my solution. Let's go ahead and do the second one. Subtract 8 on both sides. I get, oh, I made the wrong mistake here. These cancel out. Negative 2x is greater than negative 20. Divide both sides by negative 2, and be very careful here. You are dividing by a negative number, which means what do you have to do? You have to flip the sign when you divide by a negative number. So be very, very careful. This is going to become x is less than. I had to flip the sign. So x is less than a positive 10. Okay? Now that I have these two, I'm going to graph each one of them. So the first one I'm going to graph is this first one, x is greater than or equal to 1/3. 1/3 is somewhere between 0 and 1. So I'm going to make a closed circle about right there. That's about where 1/3 would be. And x is greater than or equal to, so I'm going to have a line going through right. But remember, because this is an and statement, they're connected. So I'll go ahead and draw my other dot for this inequality. X is less than 10. That's an open circle. And then we're just going to connect them like this. All right. Now another way to write this, just so you know, remember we have this new notation where we put the x between the two numbers. Okay, so x is between the 1/3 and negative 10. Notice I'm keeping my signs here. This one I had to flip when I rewrote it, so I flipped this one. But I kept that one here. So you can also write it in this notation or these two separate notations. Okay? All right, finally, let's take a look at the last exercise. This is a similar one to the one before, so what I'd like you to do is try solving this one on your own. So pause the video, try solving it by yourself, plugging in each of the values, solving it and then graphing it, and then come back, unpause the video, and check and see if you did it correctly. Okay, so pause. Okay, welcome back. I went ahead and did letter A quickly. Check your work. I got for all three of them that -6, 0, and 8 would all work. Now this says something very interesting about these inequalities, that a lot of different values are working. So I think we're going to find a really interesting solution to this inequality. All right, let's take a look at the solving. I'll do that out so you guys can see all my work. So I have 1/2 x plus 4 is less than 5, or -2 x minus 4 is less than or equal to 14. I'm going to solve. So the first thing I'm going to do is get rid of this fraction with 1/2. So I'm going to multiply both sides by 2 to cancel it out. That leaves me with x plus 4 is less than 5 times 2 is 10. Now I subtract 4 from both sides, and x is going to be less than 6. Now, you could have distributed the 1/2, but I think that's harder. I think learning to get rid of fractions by multiplying by denominator is a much easier way of solving these equations. Okay? Now we have the second part. Again, this one we don't multiply by 2, but let's divide it by -2 to get rid of that instead of distributing. So I have x minus 4. Now because I divided by a negative, what do I have to do here? Division by a negative means I have to flip the sign. So instead of a less than or equal to, I'm going to have a greater than or equal to. Really, really important part here. Okay, now my division is going to be a -7. I add 4 to both sides, and I get x is greater than or equal to a -3. Okay, now this is an OR statement, remember? So I can graph each of these separately. So I have x is less than 6, so I have an open circle here at 6. And then I have an x is greater than or equal to -3. Now this is very strange, because now all of a sudden this OR statement turned into a what statement? It turned into an AND statement. So while these two answers are correct, x is less than -6, x is greater than 3, I think that we can rewrite this solution as x being between what two numbers? -3 and 6. So I can rewrite it as, well, x is between -3 and 6. And because x could be 3, I put an equals here, and because x can't be 6, I didn't put one there. So this kind of became an AND statement, that x is greater than or equal to -3, and x is less than 6. So a very interesting solution to this problem. Okay. If you have any questions, please work on your fluency. Don't just copy the answer key. Please, please, please try these problems on your own, because they're probably the trickiest ones yet in the unit. And I'd really like to see where your struggles are, so when you come to me and say you want help, you can say, hey, I didn't understand this part of this question. All right, so take your fluency seriously, and then come ask me for help on specific items. Okay? Good luck, guys. Remember, 4.3 and 4.4 share mastery. Okay, good luck.